Hello friends, how are you? I hope you will be well friends. So friends, today we will solve the GFG problem. Problem is insert a node in a BST, right? So friends, this is a node of problem. So if you're a beginner, so little bit tough, but you know the very well BST is already sorted order, right? And we need to insert the key, right? If key it will be present, so there is no need to add, right? If key is not present in the BST, so we need to require to insert at the place, right? So question is given a BST and a key inside the k variable, right? If k is not present in the BST, insert a new node, right? And with the value equal to the k into the BST. If k is already present in the BST, do not modify the BST, right? But if there is no present, so insert the new node, right? So let's get started friends. Let's understand here. So as you can see here, the for example our key it will be what our key it will be 5, right? Our key it will be 5. Okay, so as you can see here, the this is our the BST. Okay, so friends, so first of all our program it will be start from the root, right? Because already root is coming here, right? Root node is coming here. So after that we will check the each and every step, right? One step we will right, and one step we will move on the left. Those one it's mean root. Okay, I'm writing here. If root is less than key, it's mean key it will be greater, right? Key it will be greater, it's mean where we will go, we will go on the right side, right? Because always BST concept is is the center, right? And left is always lesser than the root, and right is always greater than the root. Fine, this one is the rule. Okay, so that like if our the key presented in the left side, so what should we do? So we will compare with root greater than is equals to key. It's mean key is lesser. Where we will go? If key is lesser, so we will go on the left side. So that's why we will go on the left side, right? I'm going to write the program friends, and you will be easily to understand. But for example, here we are adding to k, right? 5. So how should be the approach? First step you will be compare these things, right? This node, firstly you will compare this node, right? So it will be match, so there it will be no need to require to add, right? And you will be if not match, so you will be go on the left and right, you will be check, you will be compare with this, right? So your key is lesser than the 5, lesser than the 8. Okay, so which one will you follow? You will be follow the root left, because your key is lesser than the root. So you will be go on the left side, so you will be compare with this, right? Your k and this root node, right? So not comparing, so you will be move. Where will you move? Again you will be check it, right? Again you will be go on the left and right, you'll be check it which one is the key 5. So you'll be compare it this thing. So this one is in the left side, you're the smaller than the key, and the right side is greater than the key. So you'll be compare the right side, and in the compare the right side, so your root node again this one, right? And after then you will be compare with again with this node, and again you will be not find. So again where will you go? So your key is the lesser than the root node, so you'll be go on the left side, and the left side you have a gone. So your 4, so 4 is a 4 node. Okay, 4 root is the lesser than the key, so your here it will be new node, it will be created, insert here 5. All right, so this like we will solve the problem. Okay, so let's get started friends. and I'm going to the writing of the program, not very big. So first of all, our condition should be if root is equals to null, right? So in this case, what we will do, if we will create a new node, right? We will create the new node, right? Root is equals to sorry, root new, we will create a new node, okay? And here I'm passing the key, right? Just like you know the very well friends, insert the key, right? This one is we are inserting key, okay? And here we will call the recursively, because here I'm writing to move on the left and right here, right? Root is root dot data is lesser than key, okay? It's mean key is greater than here. So if key our greater, okay, so where we will move, if key is greater, so we will move the right side, right? So I'm going to write here the root dot rigst, sorry, okay? And after that, again I'm calling the insert root dot right rigst, and here I'm passing the key, okay? This one is a complete. And again, if root data is greater than key, so what we will do, root dot left, we will go on the left side, left left, and insert root dot left left, okay? And here friends, and after then we will return the root, because this is a recursively call, okay friends? This one it will be move on the right side and left side, again it will be check and root node with the key, right? Key it will be greater, value it will be right side, right? It will be our the move on the right side, and again it will be calling with this, because we need to add the new node. That's why I'm creating here the new node, and there I'm passing the key, okay? And there's one root we will return, okay? So I'm going to the compile it, let's see the result. As you can see here, it has a completed. I'm going to the submit it, let's see the result. Yes, yes friends, it has a completed. I hope you will be learned something, and thanks for this watching video friends. If you have a better solution, please feel free to suggest us. Thank you.